This video will provide an introduction to arithmetic sequences. An arithmetic sequence is a sequence such that the difference between two consecutive terms is constant throughout the sequence. This constant difference is called the common difference of the sequence. The common difference, which we labeled D, is found by subtracting any terms that directly follows. Let's find the first 5 terms of the sequence, where a sub 1 is equal to 300 and the common difference is 50. Well, we already have our first term. To get a sub 2, all we're going to do is add 50 to a sub 1. So this one's going to be 350. A sub 3, add 50 more, 400. A sub 4, add 50 more, 450. A sub 5, add 50 more, we get 500. An arithmetic sequence is a linear function whose domain is the set of positive integers where the common difference serves as the slope. We can write a recursion formula for an arithmetic sequence. So a sub n is going to be a sub n minus 1, which is the previous term, plus d, the common difference. Let's write the first 5 terms of the sequence written as a recursion formula. The plus 4 tells me to add 4 to the previous term. Our first term is provided. A sub 1 is equal to negative 7. To get the next term, we're going to add 4 to that previous term and get negative 3. For a sub 3, we add 4 more. That gives us positive 1. A sub 4, add 4 more, we get 5. A sub 5, add 4 more, we get 9. We can find the general term, or the nth term, of an arithmetic sequence by using the following formula. The nth term of an arithmetic sequence with first term a sub 1 and common difference d is a sub n equals a sub 1 plus n minus 1 times d. With arithmetic sequences, we are adding the common difference over and over again to get the terms. Multiplication is shorthand for repeated addition. That's why in the formula you'll see that we're multiplying our common difference by a number to get that repeated addition. The reason that we're multiplying it by n minus 1 opposed to n, you may have thought we would, is because the first term doesn't have the common difference added to it. Let's find a sub 16 when a sub 1 is equal to 9 and our common difference d is equal to 2. So a sub 16 is going to be equal to a sub 1 plus 16 minus 1 times our common difference 2. This is going to give us 9 plus 15 times 2. We get a sub 16 to be 39. Let's try it again. Let's find a sub 150 when a sub 1 is equal to negative 60 and our common difference is 5. A sub 150 is equal to negative 60 plus 150 minus 1 times 5. So that's going to give us negative 60 plus 149 times 5. The 150th term of this sequence is 685. The next thing we want to do is write a formula for the nth term of the sequence, not using a recursion formula. We want to use that general nth term formula that we were previously using. Well, to write this equation, we need our initial term, a sub 1, and our common difference, d. Our common difference is -5. Notice that our sequence decreases by 5 with every term. And a sub 1 is given for us. A sub 1 is equal to 6. Plugging into our formula above, we'll have that a sub n is equal to 6 plus n minus 1 times a -5. I'd be inclined to clean that up. A sub n is equal to 6 minus 5 times n minus 1. In our next example, we've actually been given a recursion formula, and we want to write a formula for the nth term that is not a recursion formula. The recursion formula does give us our common difference. That plus 2 there tells us to add 2 to our previous term. That's our d. And they also gave us our initial term, a sub 1 is equal to 1. So a sub n is equal to 1 plus n minus 1 times 2. And again, I'd clean it up and rewrite that a sub n is equal to 1 plus 2 times n minus 1.